In my day job, I do some of the network performance work. So I use iperf sometime to do performance test, the network performance test. So here's something I've observed and about iperf, which kind of interesting. So I'll show you. So I have a big IP here, big IP virtual edition running on a KVM hypervisor. So yeah, I'm going to show you the test. So I'm using a Teams cattle command to show there is a 8 TMM process running on 8 cores. So like say core 0 is TM0, core 2 is TM2. So right now it's all 0 counters. There's no traffic going through big IP. So here on the client, I'm going to run a iperf3 test. So I'm running a 32 thread iperf thread to launch the test. So here's on big IP. That's the encounter. That's the counters for the interface shaper, which shows here, as you can see, TMM6, TMM4, TM0, TM2 has no traffic, it's not handling any packet. So what happens? So by the way, TMM used a hash algorithm based on the client source IP and a port to distribute the traffic across TMM process. So you would think, maybe the iperf 3 is using is using some sort of a source port of some sort of pattern about the source port. Let's see. Okay, running down. So let's launch it again. Then let's stop here. And because here it will actually show you what source port iperf3 will use. So I'm using, see the source port here? The source IP is always the same, but the source port here, oops, but the source port here is always even port. Which now we understand why it's only some of the TMM process handling the traffic. So is it iperf3 does this or something else about the source port allocation? Let's go check the iperf3 source code, see how it's handle the source port allocation. So I have iperf3 source code here, and yeah, I think the code is in the iperf TCP. Yeah. Source iperf TCP C. So for iperf3 to make a collection, it must use some kind of a collect. So let's use a collect. So here is iperf, how iperf make the TCP collections. And so do we see any code that talk about a source port allocation? So here is like a if we using some sort of a band address, then we will use a band address on the local host. So it's nothing about the source port allocation. So this is socket, create a socket, not about a source port allocation. This is for server port, so it's not about source port. So another band address condition check. Do we have source port here? So here there's a source port, but I think this source port is you specify a one single source port. So that's not a, but we are seeing even port, so that's not here. Do we see anything else here? Yeah. No. Yeah. So what it means if we don't see any source port? It actually means that it must be the Linux kernel to allocate the source port. But why would the Linux kernel to allocate the source port? Evenly. So someone have a link, and interestingly, I found this link interesting. This is a kernel patch about how to allocate source port from Linux host. So this is where it caught my eyes. In this patch, I changed the starting port in innet hash collect so that we try to favor even ports, leaving odd ports for banned users. Favor even ports. Yes, that's what iperf3 does. It's always using even port, leaving odd ports for banned users. Interesting. So what if we run iperf3 with some source? It can band to a one single source port. So I think that wouldn't work. But what if we band it to a specific source IP? Even though without banding to a specific source IP, by default, iperf3 will always using same source IP. But let's run it and see how it does. Here, let's see. Let's clear the counter here. Big start, restart, daemon. We want to clean the counter, reset the counter, and let's run the iperf 3-h. So band, we want to band to a source IP. Dash capital B is to band it to a specific interface. An interface would have a primary IP that iperf3 will use that primary IP on that specific interface. Yeah. So this guy is also bound to a specific client port, which means you can only use one single source port. That's not what we want. Okay, let's see. Okay, that's started. All 0 counters. Now run out on the PDK. I'll go to a namespace. Run iperf. History group iperf3. So let's run this guy. Band to the source IP. 32 parallel thread. Let's run. Let's see the counter. Now we see a packet has been distributed across all the TMN. Well, it's not absolutely evenly distributed, especially like this one only have one drops. But you get the idea that, you know, at least some of the traffic will be distributed to some of the TMM. So let's look at it. Oh yeah, because I think the problem is I only run it the iperf once, and so it's not completely evenly distributed. If I run it in an infinite loop, it will generate more traffic. So those numbers will be more or less evenly distributed. By the way, but let's see what source port iperf3 use. So here is as you can see here, it's no longer just even port. Seems kind of random. Some even port, some odd port. So let's run in an infinite loop. That should get the more traffic generated. So the counter can be evenly distributed. Let's see. See now TM7 got more traffic. Yes, so this is one of the interesting observation, and how a kernel patch affect the iperf 3 test. By the way, iperf 2 is the same, and yeah, so I thought it's something interesting to share with. Okay. Yeah, thank you for watching.